Assalamu alaikum, dear students. As you know, in the previous lecture, we have solved questions up to question number 6 from exercise number 4.6, where we examine the system of equations for the consistency and inconsistency. We check whether the system of equations has a solution. Okay. Now, in this lecture, we will be solving some system of equations using matrix method. So matrix method we have already discussed. For that, we should have a non-singular matrix. Determinant of the matrix should not be equal to 0. Then inverse of that matrix exists. And we can find the values of the variables of the given system of equations using the relation x is equal to inverse p. You know that. These points require to report your knowledge. Now, we will go to question number 7. So it is we have two equations here in two variables. So we will be solving these equations by using matrix method. Okay, we will write this system of equations first of all in the matrix notation. That's ax is equal to b, where a is the this is matrix of cooptions, and x is the matrix of variables, b is the matrix of constants. Determinant of a we have that's equal to 15 minus 14, that is equal to 1, that's not equal to 0. The a is non-singular matrix, therefore its inverse exists. Okay, if its inverse exists, we will find its inverse. How can we? First of all, we have to find the adjoint. So adjoint, we have to find the cofactors, and we have to transpose the matrix of cofactors, and we have to use a inverse is equal to 1 by determinant of a into adjoint of a. Yes, that's it. Here it is the inverse. So solution is given by x is equal to a inverse b. A inverse we have found here, and b is the matrix of the constants. We'll multiply them, we'll get 2 minus 3. So by the equality of matrices, we have x is equal to 2 and y is equal to minus 3. Okay. Similarly, we have other questions of this exercise. So all other questions from question number 8 to question number 15, they are same. Let's see how we can solve question number 15. It's a 3 cross 3 system of equations in 3 variables, and we have 3 equations. So how to solve this question? The procedure is same. We have the system of equations, okay, and we have this matrix is given. Question says, first of all, you find A inverse, then we use this A inverse to solve the given system of equations. So A is this. First of all, we'll find the determinant of A. Determinant of A, that's equal to minus 1, not equal to 0. After that, we will find A inverse, that's equal to 1 by determinant of A into adjoint of A. Okay, so 1 by determinant of A, that's equal to 1 by minus 1, that's equal to minus 1. And this is adjoint of A. Adjoint of A, you know how to calculate. Multiplying this minus inside the matrix, it will get multiplied to every element of the matrix. So we have this as inverse. So if it is inverse, we have to find now this, and this is if it's inverse, now we will go to the system of equations to solve that. So this is the system of equations. We will write the system of equations in the matrix notation. So this is the matrix notation of this system of equations. Ax is equal to b, where this A is this matrix, b, x is the matrix of the variables, and b is the matrix of the constant terms. So the solution of this system exists because determinant of A is not equal to 0, and the solution is unique solution given by the relation x is equal to A inverse B. So A inverse we have calculated, B is already given there, so we will multiply them and we will get this 1, 2, and 3. By the equality of matrices, you have x is equal to 1, y is equal to 2, z is equal to 3. So we have calculated the values of the variables. Same as question number 16. It's somehow a practical example of application of matrices and determinants. For example, you go to the market and you see there the cost of the 4 kg onion, 3 kg wheat, and 2 kg rice is 60. The cost of 2 kg onion and 4 kg wheat and 6 kg rice is rupees 90. And the cost of 6 kg onion, 2 kg wheat, and 3 kg rice is rupees 70. We have to find the cost of each item per kg by matrix method. So the question is very simple. We don't know what is the cost per kg per item. We will take it X, Y, and Z for onion, wheat, and rice respectively. Okay, we will write it in the matrix notation like this. 4 kg of onion means 4x, 3 kg of wheat means 3y, and 2 kg rice means 2z. Similarly, other two equations. Okay, here is the cost accordingly. Now, this is the system of equations in purely in the algebraic form. We will write it in the matrix notation. It's Ax is equal to B, and A is here this, X is this, and B is this. Determinant of A, that's equal to 50, not equal to 0. We will find the cofactors. We'll write the matrix of cofactors and find the transpose of that. That means we'll find adjoint of the matrix. Okay. After finding the adjoint of the matrix, we will find the inverse of the matrix. So inverse of the matrix is 1 by determinant of A into adjoint of A. So this is this way we can find its inverse. So this X is equal to A inverse B now, using the value of A inverse, and here it is B. We have found these two. Already we have found this A inverse. Now we'll multiply them and we'll get this. Dividing by 50, you'll get this. So X is equal to, by the equality of matrices, X is equal to 5, Y is equal to 8, Z is equal to 8. So cost of each kg of onion is 5, and that of wheat is 8, and cost of each kg of rice is also rupees 8. So this way you can solve the practical examples of our day-to-day life with the help of matrix method also. Thank you for joining the class.